Alright, what is going on, guys? So today I will be attempting to solve problem 14 of the AMC 2016B for 12th graders. So the question is, the sum of an infinite geometric series is a positive number s, and the second term of the series is 1. What is the smallest possible value of s? So we know by the formula there's a geometric series formula, and you do learn this in algebra 2, I believe, so hopefully you will remember this formula. But it's the sum of a geometric series. If you don't know what a geometric series is, it's just the sum of all the numbers in a geometric sequence. But this is an infinite geometric series, I believe. Yeah, an infinite geometric series, so this one is different. I mean, it's still the same formula, but simplified. So the formula is 1 times, I believe it's 1 times a sub 1 all over 1 minus r. So this is the formula. S is just equal to a sub 1 over 1 minus r. So now we're going to try and form an equation that helps us find this s value. And we're going to try and minimize some values in order to get the minimum value of s. Alright, so we're going to either try and maximize the denominator, or we're going to either try and minimize the numerator in order to get this s part minimized. So there's two variables in here. You have a sub 1 and r, and you want to find a way in order to kind of correlate these two together. So let's see what they give us. The second term in the series is 1. So that means we can say a sub 2 is equal to 1. So that's going to help a lot. And by the geometric sequence formula, I believe you can get a sub 2 is equal to a sub 1 times r to the power of n minus 1, where 2 is n. So in this case, if we just substitute it in, 1 is equal to a sub 1 times r 2 minus 1, r to the power of 2 minus 1. So 1 is equal to a sub 1 times r. And now we have perfect equation that shows us the relationship between a sub 1 and r, and a sub 1 is inversely proportional to r. So that does help, because as a increases, r decreases, or as r decreases, a increases. So that means we have 1 over r is equal to a sub 1. You can go 1 over r or 1 over a sub 1 is equal to r, but I prefer this way. This way just is a lot faster in my opinion, or more efficient. So you just plug in 1 over r for a sub 1. So then you have 1 over r times 1 minus r. So the sum is equal to this. And that's eventually equal to r squared, negative r squared plus r. So now in order to minimize s, we're going to have to maximize this denominator. Does that make sense? Because this top is a constant, it can't be changed at all, which is a great thing. So we're going to try and maximize the denominator. So now we know that this is a quadratic, and this is a negative quadratic, which means that it's going to be an upside down parabola. And that's perfect because this upside down parabola has a maximum at the vertex, as learned in algebra 1. So the formula to finding the vertex is negative b over 2a. So we know that b is the coefficient in front of this term, and a is the coefficient in front of this term. So that's going to be equal to negative 1 over 2 times negative 1, which is equal to 1/2, is equal to r, because we're trying to find the maximum value of r. So now we just plug that back in. 1 over 1/2 times 1 minus 1/2 is equal to 1 over 1/4, which is equal to 4. And therefore, you have s equals 4 is your minimum value. And for problem 14, E is your correct answer.